Hi, I'm Isyov. I'm the machine my creators made, a smart machine to help people in the production of ice. It may seem like it was easy to make, but everything has a difficulty. Sadly, I'm just a design and set of simulations, so I don't really exist. And that's because a Chinese guy ate a vampire and now the world is in a pandemic. My creators of design, automation, and manufacturing did their best, calculating, doing, and researching. It all came about when a machine before me was doing the same thing, only it wasn't as cool as me. Kind of this.
One hour later.
Just like that machine, there are many more. There are different types of manual sealers that you can find in online stores, but there are also automatic sealers. Only these, unlike the manual ones, are very expensive and big. Now, you are seeing my first designs in a notebook. Finally, I was made to be small, cheap, and with a good production capacity, being thus competitive with others like me. I can tell you that I am 614mm tall, 260mm wide, and 652mm long. I'm made of 16-gauge stainless steel sheet with a half-inch cubic profile.
Now, here you have the presentation of what makes the machine. In general, most of the products are stainless steel. This because the machine works with liquid food, and this material has a high resistance to bases, acids, and chlorides. Acrylic sheets for electronic components. Stainless steel press block. Bulk spindle of iron and plastic. Linear bearing of iron. Press sensor. Polyethylene supply resistor base. Resistors. Stainless steel press. Servo motors. 5mm diameter cylinder and bearings. Stainless steel guide holder. Base for bearing and 8mm speeder. 1205 volt screw. Guide rods.
The objective of the machine is to make 700 ices of 50 centimeters per hour. We decided to use a multiplier system based on a threaded part and a spindle. To meet with the production of ices, the press has to slide 50 centimeters from top to bottom and 50 centimeters from bottom to top in 5.14 seconds. So we needed a motor with a high speed and high torque. This motor has a speed of 700 rpm and a torque of 64 kilograms centimeters. making it ideal for the system. The next step was to find a ball screw that had the correct threaded pitch. This ball screw has a diameter of 12 mm and a pitch of 5 mm. The advantages are high precision, high speed, low friction. The ball spring has the same diameter and threaded pitch as the ball screw. This is how to do a complete process in 5.14 seconds. The ball spring will be screwed to a stainless steel block of the following measurements. This block serves to hold two servos of 11 kilograms of torque and a press. The press is made of stainless steel and has the following measurements shown in the picture. A study was carried out at SolidWorks to find out the stress, deformation, and safety factor of an important part such as the press. Taking into account that the servomotors have a torque of 1.078 Newton meters. Each between the two servomotors will exert on the press a force of 75.70 newtons. This picture shows where the press is most stressed. In the numerical calculation, the greatest stress is where the servomotors transmit their torque, reaching a tension of 2.18 GPa. In the analytical calculation, the stress is 2.58 GPa. As we can see in the graph, the elastic limit supported by stainless steel is shown on the left side. In the middle, the stress calculated numerically is shown, and on the right, the stress calculated analytically is identified. Deformation, like the stress, the maximum deformation occurs where the servomotors transmit their force, and this deformation is 7.586 times 10 minus 6, which is equal to 0. The safety factor is very big, reaching more than 100 in both cases. To prevent the block from rotating on its own axis, two 20 cm guides with a 8 mm diameter were added. There's a slide on two linear bearings L, M, H, 8, L, U, U. Its internal diameter is 8 mm and its materials is iron. It is a ball bearing. These are screwed underneath the block to get a better grip. The way in which the movement of the motor is transmitted to the rod is by a rod coupling. The rod coupling has a 8 mm diameter connection for the rod and another 10 mm connection for the motor shaft. This type of coupling was chosen since it adjusts to the measurements of the motor and the ball screw, and it's made of aluminum. In conclusion, the motor turns 60 times every 5.40 seconds, producing a linear movement in the block of 300 mm, ideal for processing an ice, just generating 700 ices per hour.
We will be using an Arduino Mega, because it is a microcontroller that allows to work with spike voltages that are used by the sensor that we will use in the machine. It has a total of 54 inputs or outputs. It also has a RAM memory of 8 kilobytes and an EEPROM memory of 4 kilobytes. In addition, they show it usually very economical on the market, which could also reduce the price of the machine. Two limit switches indicate the start and end of the press of the stroke. 4 infrared sensor. Very safety machine does and start the process if there is activate. 1 CNY70 by detection system. 1 water sensor, water detection, edge bridge model, relay model, water pump. Consumed in kilowatts. The table shows the completion of sensor and actors as well as the amount that will be used in the prototype. It is estimated that the machine will work 8 hours per day, so the total cost per month will be 58.27 kilowatts. For the electrical connection, a phenolic table will be used. According to the Mexican official standard PROI Num 001 CD 2018 Electrical Installation, Article 658 Overcurrent Protection. The choice of conductor cable was made based on amperage and temperature staples. For Arduino phenolic boards and sensors connections, 24 AWG with 80 mA. Electrical connection, 14 AWG with 15 amperes. Resistors, motors, and relays, 10 AWG with 30 amperes.
First, the container must be filled with water, if there are no leakage. The process won't start because the container has a water flow sensor, but stop the process in case of water routing. The next step is to place the tubular folding in back of the tube, which one can be removed. At the end of the bag, a piece of black tape should be placed, so the CNY70 sensor detects the end of the bag and stop the process to avoid spilling liquids. Once this is done, ensure that an emergency stop is not pressed. When the machine is turned on with the switch, the block will be placed in the upper limit switch and open the press to place the bag. Once the bag is placed, it is tight and we turn on the pump with the pump button. Wait until you feel a noise of 15 cm approximately. When this well has enough liquid, the pump is turned off. Now, the automatic process is start with the start button. In the automatic process, the four sensors that are in the water street on to avoid anything is inside of the mechanisms avoiding accidents. Automatic process 1. The Arduino Mega activates the movement of the servo motors causing the closing of the press, and at the same time, it activates the water pump. 2. A sensor integrated in the blocks detects the closing of the press, so it activates relays and the operation of the edge bridge. 3. As the block is in the top, the edge bridge turns the motor causing the block go down. 4. At the same time, the 3 activated relays will control the 3 resistors. 5. The upper and lower resistor are only activated for a few seconds to allow the bag to be cut. 6. The intermediate resistor is activated for a longer time to cut the bag. 7. When the lower limit switch is activated, the press opens. 8. When the press opens, the motor turns to the other side to make the block rise. 9. When the upper limit switch is activated, the process is repeated. To stop the process, the stop button is pressed. At this moment, the pump is turned off to stop supplying liquid. Regardless of where the block is located, the process will only end when the upper limit switch is activated.
Now, you are in the manufacturing process, that is the final part. Within this project, the main part of all the process is a ball screw. This screw can already be obtained in places where it is sold in diameter and by meters. So, the only thing we have to do is to buy it and make a routing for measurement of the coupling on the head of the screw. It will only be a matter of cutting into 276 mm long with the help of a curing disc and with the routing machining. So, we will do the routing of a diameter of 8 mm with the lathe and not with the CNC machine. The next process is with a CNC machine. This process is assigned with work plans where routing and contouring is selected, depending on what it is required. So, in this case, we will work on the block and press with this machine for a better finishing. This machine will help us to give a better finishing to those necessary pieces, thanks to its easy use and capacity of machining. Eventually, we will obtain the code which allows us to put it into the machine. So, as we can see here, we have the different parts that make the machining up. Each line has its function. For example, when we declare G21 in the second line, we have the units in millimeters. The fourth line in N3, it refers to the declaration of coordinates increment and the zero machine. In N4, the tool change actions with T0 and M0. Finally, in the line N5, we find the RPM we declared in the program. The machine has the objective to work with products of food, so the welding which will be used is the TIG, for the reason that this welding allows us to reach small places and it is the best choice for working with the stainless steel. A pure tungsten electrode and argon gas will be used for protection at the moment of welding. The welding machine will be of direct current, inverter, because to the amperage and manipulation we are facing, this machine is the best which benefits us to the most. In general, the process we are using is the electric arc process with gas protection, because here we find the advantages of quality, precision, and an excellent manage in aluminum.
Finally, for a better aesthetics of the machine and compliance with a 100% of quality standards to go to the market, some procedures are carried out. Number 1. Sand the profiles to make it smooth. Use 400 with sandpaper for its ideal complement before applying the base paint. Number 2. Clean the steel parts. This is done with the help of with vinegar. Number 3. Cover areas that won't be painted and put unnecessary or assembly material. The BNA 22 coat of wheel is used here, because it is the best option without sulfur, iron, and chlorine. Excellent for the steel we are handling. Number 4. Apply primer to the steel. Primer paint. Number 5. Paint with enamel paint. Thanks to the easy application, cleaning, drying, and covering, just paint it with a brush.
Coast and boot kits. The coats are divided into two stages. The manufacturing stage is where the price is included to create the machine from scratch, as a real material, machining, welding, and stuff. In the control stage, the prices of all the electronics used in the machine, such as the motor, microprocessor, cables, and stuff. As shown in the graph, most of the expenditure is made in the manufacturing stage. This is due to the materials used, such as the stainless steel, the manufacturing of the machining of some parts such as the block and the ball screw. Then, the total cost of the production of a machine is 60,369.57 pesos. Business objectives: have a marketing in Latin America. Increase efficiency and reduce the initial cost of companies that are starting this business. Generate more micro-enterprises through easy ice production. How will you manage to have a market in Latin America? A page will be developed where all the characteristics of the machine will be put. Also, videos and costs in this one are included. At the same time, the machine will be sold through sites such as Amazon and Free Market. It will be promoted on social networks such as YouTube, Facebook, and Instagram. All this, the mass production of the machine, will generate new jobs. This without counting the jobs that the micro-enterprises will create indirectly. Replicability. Most of the pieces that make up the ice hub are available in both physical and online stores. The few pieces that are machined by us are easy to machine. Taking into account these points, the machine can be easily replicated. Competence. In the market, there are different types of machine for making ices, but these have a high price that ranges from 80,000 pesos to 200,000 pesos, as they are aimed at large industries, not counting their large size. What differentiates IceHub from other machines in the market is its low cost with a group production of ices, which make it sustainable for micro companies. Scalability. With mass production, the cost of production can be significantly reduced by making more machines with a minimum investment cost. Risks. 3 pieces are only made for us. What is the solution? Give 5 years of durability. The size of the ice is limited to 15 centimeters. The solution is implement an actualization with the machine. Without the whole process I went through, I wouldn't exist right now. Fate has given me its reward. I witness what my creators are capable of, and it's really more than you see. I am IceHub, and I give this message of thanks to my collaborators. And here we are. We are working.